Test, test. Hope you can hear my voice and the slide. It's the questions. Can someone confirm? Can hear my voice and the slide?
Yes, sir.
Okay, good. On Tuesday, group 1, 2. I discussed question 1 and question 6. 1 and 6. Yesterday, Thursday afternoon, Thursday morning, question 1 and 6. Tuesday afternoon, Tuesday 2, 1. It's question 2 and question 5. Question 5. So now I'm going to discuss question 3 and question 4. Question 3 and question 4. Okay. Question 3. Check. Okay, question 3. Circuit with 3 branches having single resistor, inductor and capacitor respectively are connected to parallel. So it's parallel across 100 volt and 50 hertz supply. So this is the source power source, 100 volt and 50 hertz supply. By considering R, resistor value of 10 ohms, inductor value 0.1 Henry, and capacitor 100 microfarad. Calculate the current in each branch. Okay. The current in each branch, meaning you have to find IR. If you see the circuit there, IR, IL, and IC. Okay. Those one is current for each branch. So the current that goes through resistor, current goes through inductor, and the current that goes through capacitor. Okay. B, supply current. Supply current means IT, I total current. Total current means IR plus IL plus IC. Okay. C, the phase angle between the supply current and the supply voltage. Phase angle. Yeah. Well, let's start with the first one then. The current of each branch. IR, IL, and IC. So since this is in parallel, okay, the connection is parallel, meaning the voltage for each branch is equal to the voltage of the supply, right? Remember the characteristic of parallel connection? In parallel connection, the voltage for each run equal to the voltage of the supply generator. That means VR, let me write here. So since the power, the source of the supply is 100 volt, 100 volt, that means the VR here, the VL and VC, okay, VR, VL equal to VC equal to V source, VS1 equal to 100 volt. Okay, equal to 100 volt. Yeah, so how do we find I for each brand? Simply by using Ohm's law. So IR equal to VR over R, right? So VR equal to 100, R equal to 10. So IR equal to 10 ampere, right? What about IL? IL equal to VL over XL, reactance, inductor reactance. So the formula for XL, let me write it down here. XL equal to L equal to 2 pi FL equal to 2 pi. F is 50. L is 0.1. Is it 0. Yeah, 0.1, huh? 0.1. 0.1. So 0.1 times 50 is 5. 5 times 2, 10. 10 times pi. Pi is 2.14. So this one equal to 51.4 then. Ohm. So IL equal to 100 divided by 31.4. Equal to 3.18. Check. 100 divided by 31.4. Yes, 3.18. So you have here 3.18 ampere. Okay. Next is IC. So using the same formula, IC equal to VC over XC. But then the formula for XC is 1 over, let's see. So expand this one. Expand equal to 1 over 2 pi FC. So, 2 pi F is 50. C just now is 100 micro. So 100 micro means 100 times 10 to the power minus 6. So 10 to the power minus 4 then. Yeah. So 100, this is 2 times 50, 100. So over pi ohm. Okay. So 100 over pi equal to pi or 3.14 ampere. Okay. That would be for A. Yeah. What about B? Supply current, I total. So you just add all. Okay. Then don't forget I total. Okay, now what? Delete this one first. This one. And this one. Okay. So since we have both inductor and capacitor, okay, remember inductor and capacitor, they have 90-degree difference. They have 90-degree difference. That means they always against each other, the opposite. You know, the terms lead and lagging. IL is always lead over IC. IC is always lag over IL. That means the direction is the opposite against each other, and that will affect the sign. So if IL is plus, that means IC is minus that. Okay. So since that's the case, so if you want to find IT total, equal to IR IL IC. You check again the slide in textbooks. So 10, 3.18, 3.14. Okay, you will get around 10 also, 10 and 10. That's for B. C, the phase. The phase angle between the supply current and the supply voltage. So since we found the current for all resistor, capacitor, inductor, so we're going to use I then, the current. Where the formula is inverse tangent. Inverse tangent of IL minus IC over R. Okay, the angle. So IL just now is 3.18, IL 3.14. So 0.04 over 10. Okay. What's the value then? 0.0. 0.04. Check. Someone find what is the value here, the angle? Okay, you find by yourself. Huh? This is a calculator, inverse tangent of 0.004. Is it 0. Use radian, not degree. Use radian. I think you use Wang and who's this Gloriana. I think you use a degree here. Use radian mode instead of degree. Zero point 0.004. Yes, but then use radian mode. Or you can convert, or if you will not use radian mode, convert 0.004 into degree, then can use degree. Then. Okay, let me check. One get the answer. Can use online calculator. I think also discuss this in question. Okay, yeah. Let me know later if there's still a problem. If you have a calculator, you can use online calculator and calculator there's a radian and degree mode. Okay. Okay, we proceed to question 4. 1500 nanofarad. Nano, micro, nano. Is connected in parallel with a 16 ohm resistor across a 10 volt 10 hertz supply. 10 volt 10 hertz supply. Calculate the current in each branches. So find IR and IC. Supply current. I total. Circuit phase angle. Okay, again, the angle. Circuit impedance, Z. Power consumed, P. Apparent power, S. Circuit power factor, PF. And the phasor diagram. Okay, phasor diagram. So it's also straightforward question. So A, IR, IR equal to V. Remember, this is parallel. This is parallel. So the voltage is equal in each branches. Okay, V over R. V10, R is 16. So around 0.625 ampere. Okay, now I see. I see V over XC. V is 10, XC 1 over 2 pi F. F is 10, right? Yeah, 10. F is 10. C 2 pi FC. C is 1500 nano. 1500 nano is 10 to the power of minus 9. So calculate this one again. B. I see. So you get C circuit phase angle. B. Forgot we must skip B. B I total. I total. So equal to IR plus IC. Okay. C circuit phase angle. Circuit phase angle. Inverse tangent, like just now. So since we have only capacitor and resistor, so this one IC over IR. Okay. Don't forget this one in this case use radian instead of degree. Radian. D circuit impedance Z. Circuit impedance Z. Z equal to V over IT. V is 10. IT, okay, you get from here IT just now. Here IT. Okay. And then power consumed. Power consumed. P. Remember, power consumed is only involve the R. Okay, P resistive. P resistive. So the formula is IR times R. Okay, IR is 0.625. 0.25. R is 16. Yeah, 16. So times 16. You get how many watt there? Okay. F apparent power S. If you look at this slide, S equal to P plus JQ. We already have P. This is P. Now we need to find Q, reactance power. Reactance power. Power that involve the reactance, the capacitor in this case. So Q equal to IC square over XC. Okay. You just now IC, you have IC, and XC also you have measure IC. So you get the number then. After you get a number, you put in here. Okay. Don't forget the unit for Q is voltage ampere ratio. VAR. 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 For P is what? Okay, next power factor. Power factor equal to cos the degree. We have 1 degree here just now, this one degree. So put the degree into this one. So you get, find the cos value, you get the power factor. Okay. Last one is phasor diagram. Phasor diagram. So have to draw them. Okay. The horizontal one, the pure resistive, is P. P, you put the value there. How many watt? Okay. This one, how many watt? This one. If you multiply this, you have 0.625 square times 16. 6.25 watt. So this one 6.25. 1. And then the horizontal one is Q, reactance QC. Put the value also, calculate the value. You have measure now in F, this one. And the diagonal one is S, apparent power. S in here. This is S. The unit is volt ampere. You get the S value from here. So P plus JQ. P plus JQ. So put the value. P plus JQ. So put the magnitude. This is the S in magnitude. The magnitude will be. The magnitude for S P square plus Q. Magnitude for S. Because this is a triangle. Pythagoras, use the Pythagoras law. Okay, that's all. If you have anything to ask, number 3 and 4. If no, then
Sir,
yes.
tomorrow is test, right?
No, tomorrow is test. Tomorrow is test. I think we agree from before the semester break, right? Tomorrow is test.
Okay.
Okay, don't forget the test tomorrow. Start at 3, 1 hour, perhaps. Let's see. It's all online, huh? So you submit also your answers at the end. Okay, that's all.
So
see you. Sorry?
The test from what time, sir?
Our class time, normal class time, 3, right? 3 o'clock. 3 to 4.
All right.
Let's see,
Thank you, sir.
3 to 4. Okay?
So until what chapter?
Chapter 3, transformer. Okay? It's all there are majority calculation. There are few theories on a small portion. So, and it's open book, right? So, I don't think you have any problem. Okay? Any more questions? No, huh? Okay. We stop here. Don't forget your test tomorrow. Okay. See you tomorrow then. Thank you.
Thank you,
Sir.
Okay.